This is the video for Mod 12, Lesson 2A, Lines Tangent to a Circle, Part 1. The goal of this lesson is to verify a tangent segment and then applying properties of tangent segments to find lengths. So a few things we want to remember. So remember a tangent line, which we saw in a couple lessons ago, is basically a line or a line segment, or it could even be an array that intersects a circle at only one point. And so we had that, like for example, line L would be our tangent line, and it's tangent at point T. We have a few properties that occur when we talk about a tangent segment or a line that's tangent to a circle. So one property we're going to see is that if I was to draw a radius that intersects the point of tangency, it's actually going to create a right angle with that tangent segment, or they're going to be perpendicular, right? Because perpendicular means intersects to form right angles. So we're going to see by when we form right angles within a circle, we can use all of our triangle properties that we learned about with trigonometry, Pythagorean Theorem. Everything with right triangles can be used for a circle when we create a right angle within that circle. So that's what we're going to kind of see the theme with tangent segments and right triangles. The first example we see here is it says FG is a radius to circle F. So we actually can see that FG goes from the center to a point on the circle, and we have that and then they do tell you the length of HF, which is this entire length, is equal to 12. That's going to be really important for some examples. If they don't name the whole segment, they might only just have meant this little piece. But since they actually named it as HF, we knew that this whole thing was 12, not just that little piece. We then have to determine, well, is the segment we're looking at, is this segment HG going to be a tangent, right? Is that a tangent segment? And so the way we do that is if this is a tangent segment, this would imply, and we don't know if this is true, that would have to be a right angle, which would mean that this has to be a right triangle. So what we're going to do is we're going to test, is this a right triangle? If it forms a right triangle, then the answer would be yes, it is a tangent segment. If it does not form a right triangle, I'm going to put a question right here because we don't know, it is not a tangent segment. If we looked at this as a right triangle, we would actually see that 8, or the tangent segment, the possible tangent segment, acts as a leg. So 12 is actually your C, or your hypotenuse. So I'm going to go ahead and test this, and it's kind of like what we did in one of the previous units. I'm going to test, well, does 12 squared equal 8 squared plus 6 squared? Do those equal the same thing? I get here 144. I'm going to test, does that equal 64 plus 36? We actually get 144 equals 100, which is not true. Or I should say that's actually false. So what that means is it's not a right triangle. Which means that it's not a tangent segment. Or another way you can think of it is we're trying to determine if GH is tangent. You might also have written instead GH is not tangent. And then that would also have done that. So basically we're using the converse of the Pythagorean theorem to show that that's not a tangent segment. In example, the next example is kind of the same concept, just the diagram looks a little different. So notice it says JL is a radius. determine if KL is tangent. So notice they don't tell you what KJ is. We have this little piece is 9 here. So what we actually know though is, so this JL is a radius. But that little piece, and we didn't have a point for it, so I could even name it a point. I can maybe call this maybe point M, just so it doesn't get confusing. You can see KM is actually what they're saying is 9. So we can't really assume they're talking about the whole segment. They didn't state that. So I can only assume it's for that length that little piece up to the intersection. So what that means is this is actually 8 as well. And this entire length is 17. A way that I also knew that I probably had to do that is you can see 15 is a leg, and if I made 9 the hypotenuse, that wouldn't really be possible. You can't have a hypotenuse be shorter than a leg. So that's another clue that I probably had to, 9 only meant that piece. So now we're going to go ahead, and the goal is to test if KL is tangent, right? So again, we're going to see, well, does this make the 17, 8, and 15, so these 3 sides, does this make a right triangle? So we're going to go ahead and do Pythagorean Theorem. We have 17 squared equals 15 squared plus 8 squared. 289, I'm going to see, does that compare to 225 plus 64? When I put that together, I do get 289. So I actually get something that's a true statement, which means that we have a right triangle, which means we have a tangent segment, right? Because if this is a right triangle, we have a right angle, and if that's a right angle, KL is a tangent segment. So I would say KL is tangent. And if you want to get more specific, you can say 2 circle J, but it's a tangent segment. The second topic we're going to see is still tangent segments, but this one, they're going to tell you they're tangent, and we're using it to solve for a different length, right? So notice they're giving you it's a tangent segment, and the goal is to solve for the variable. So the idea here is we're still using right triangles, we're still using Pythagorean Theorem, but we just know it's tangent, so we're solving for an unknown. So when they say the following given the following tangent segments, we can see JK touches the circle at one point, and so they're telling you that JK is actually a tangent segment. So really what happens is we have a right triangle in this problem. We also know that, again, unless they tell us specifically how a segment's named the length, I only assume between the 2 endpoints that's the length there. So if this is 3.5, that's a radius. I know this is also 3.5, so ML has to be 3.5, which means the entire length is 3.5 plus 3.5, which is 7. And so now we're going to go ahead and use Pythagorean Theorem, but this time to solve. So if this is my right angle, this is my hypotenuse. So I'm going to go ahead and say x squared equals 7 squared plus 6.4 squared. And then I'm going to go ahead now and just simply solve with Pythagorean Theorem. So I'm going to get 49 plus 40.96. When I put it together, I'm going to get 89.96. And then if I do the square root, we're going to get that length to be 9.48 or 9.5. So this length is 9.5. The last example is a little more challenging, but again, it uses a lot of the properties we saw last semester with polynomials. So we know here that we have a segment. They told us already in the previous problem it's tangent. So we have a right triangle here. We have the radius. That's what, we have a couple radii in this circle. We have a radius of x. And then we have AD is actually also equal to x. So these are both equal to x. A way that I know that I'm not going to just assume it's 18 is 18 is smaller than 30, and 30 is a leg. So we know the hypotenuse has to be greater. If I need the hypotenuse, though, I can put these together. This becomes x plus 18 as the hypotenuse. And the goal is to solve for x, so we're going to go ahead and just do Pythagorean Theorem. So our hypotenuse goes on a side by itself. I have x plus 18 squared equals x squared plus 30 squared. If I square a binomial, it's the same as writing it twice. I'm going to distribute. We get x squared plus 18x plus 18x plus, and then if I square 18, I'm going to get 324. So x squared plus 36x plus 324 on the one side. And then on the other side of the equal sign, I have x squared plus 900. And then when we go ahead and solve, it's actually kind of interesting to solve. We do have a quadratic, right? There's an x squared in the problem like we saw last semester. But we're going to find if I move the x squareds to the same side, they actually cancel out. So it actually works out kind of nice. It does end up being a linear equation, because those x squareds cancel out. I'm going to subtract 324. So when we go ahead, we get 36x is equal to 576. And then when I divide, I'm going to get x to be 16. So that actually ends up being the radius. So x is equal to 16. And then if I put this together, you could see this would have been 16 plus 18, which is 34. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.